Hello students, welcome to standard 9 subject mathematics chapter 6 lines and angles. This is lecture number 5. Now we will see the next topic in this chapter is parallel lines and a transversal. Parallel line and a transversal, about this you will understand. So here the first definition we have as what is transversal. It is a line which intersects the two or more lines at distinct points, means different points, is called a transversal. You can understand with this figure, this transversal as you can see, the line L is intersecting line M and N, two lines it is intersecting M and N at two distinct points, say P and Q. So this line L is a transversal for M and N. That is here also here in figure, line L is a transversal for M and N because it is intersecting the two lines in two distinct points. Here we observe that four angles are formed at each of the points P and Q. At P point, four angles are made. This and this. 1, 2, 3, 4. At Q also four angles are made. Here, and here. So 5, 6, 7, 8. The name is given. So that is also given here. Let's name the angles as 1, 2, 3, 4, 5, 6, 7, 8. All the names are given. Now, if you see here, this angle 1 and 2 on above side and 7, 8 is downside. It is on outside looking angles. So they are called 1, 2 and 7 and are called exterior angles. Exterior, why they are so called? Because they are in exterior part, outside part. So 1, 2, angle 1, angle 2, angle 7 and angle 8 are called exterior angles. And angle 3, 4, 5 and 6, 3, 4, 5 and 6, they are coming inside, so they are called interior angles. Right? Outside looking angles 1, 2, 7, 8 exterior, inside looking angles 3, 4, 5, 6 are interior angles. This way. Now we will have some pairs of angles. Some pairs of angles are categorized in four parts, corresponding angles A and B as alternate and interior angles, C as alternate, exterior angles, D as interior angles on the same set of transversal. So we will see one by one pairs. So pairs of angles, corresponding angles are four pairs you will find. Which type of angles are called pairs of corresponding angles? So they are angle 1 and 5, angle 1 and 5, 2 and 6, 3 and 7, 4 and 8. So there are four pairs of corresponding angles. How to understand this? We can understand by the transversal is that on its left up angles are left side and upside angles are 1 and 5. So angle 1 and 5, one pair of the corresponding angles. Second, on the transversal right side, upside, right and up, right side and upside of these two angles, 2 and 6 angles. Angle 2 and 6 are so here we continue that angle 2 and angle 6 are of the transversals right side and upside, so they are also corresponding angles, second pair. Then the transversals right side and down there, downside M and downside 7, 3 and 7 angles, angle 3 and angle 7 are corresponding angles. Similarly on the right side, downside are angles 4 and 8, so angle 4 and 8 are corresponding angles. So these were four pairs of corresponding angles we have, right? Now alternate interior angles, they will have two pairs. To see this, we have to see the alphabet Z as Z. We can see Z this way. It is Z. And with its corners are 4 and 6, Z corners are here 4 and here 6. So one pair is angle 4 and angle 6. The reverse side also we have to consider. Reverse side of this way. This way reverse side. And its corners are this and this. So angle 3 and angle 5 is also one pair of alternate interior angles. So alternate interior angles are 2 pairs, 3 and 5. These and this of these Z corners, and second pair 4, 6, angle 4 and angle 6 of this Z corners. So they are interior, so interior angles. And alternate exterior angles means outside we have to see edge to edge, corner to corner. This side 1, so this side 7, outside angles, exterior therefore. So 1 and 7. So alternate exterior angles are 1 and 7 this side, and in here exterior angles are 2 and 8 at the diagonal outside angles. 2 and 8, angle 2 and 8 are the second pair of exterior alternate exterior angles. So this way 2 pairs of exterior alternate angles we have. Now D is interior angles on the same side of transversal. As the heading is, same is the here. The same side of transversal we have to see. This is the transversal. Its same side means if you are looking on left side, you have to see on the left side only. And in that also interior angles. So on the left side interior angles are, this side 4 and 5. Interior angles on the same side of transversal 4 and 5. On the right side 3 and 6. So 2 pairs here also we have. Angle 3 and 6 on the right side, same side, interior 3 and 6, and 4 and 5 on the right side, on the same side, interior angles 4 and 5. So the interior angles on the same side of transversal are also 2 pairs, they are 3 and 6, these 2, and 4 and 5, these 2. Right? One more thing you have to understand here, that interior angles on the same side of transversal are also called consecutive interior angles, or they are called allied angles, or they are called co-interior angles. So 4 different names are there that you have to remember. If in a question it comes, you have to remember this, that if allied angles, that means you have to understand interior angles on the same side of transversal only. Consecutive interior angles, allied angles, co-interior angles, all are same. And they are 2 pairs, and they are angle 3 and 6, same side of transversal, same side of transversal. Second pair is 4 and 5, angle 4 and angle 5. This is the all pairs of angles. Here we have understood 4 pairs, corresponding angles, alternate interior angles, alternate exterior angles, interior angles on the same side. Now next, we have drawn the next figure in which these 2 distinct lines were the MNN. If they are parallel drawn, we have drawn parallel MNN. Only the difference between these 2 figures is here the MNN line are not parallel, and we have all the pairs of corresponding angles and alternate interior, alternate exterior, and interior angles on the same side of transversal. But if the lines are parallel, we have these axioms, 2 axioms 6.3 and 6.4, and 4 theorems 6.2, 6.3, 6.4, 6.5. So we have to refer this if the lines are parallel. What happens? If a transversal like this L intersect 2 parallel lines, these parallel lines, if the transversal is intersecting the 2 lines and that 2 lines are parallel, and one more condition, then each pair of corresponding angle is equal. That we have seen 4 pairs of corresponding angles, they will be all equal. Means angle 1 is equal to angle 5, angle 2 equal to angle 6, angle 3 equal to angle 7, angle 4 equal to angle 8. But when it is, if the lines are parallel and transversal intersecting that 2 parallel lines, then all 4 pairs of corresponding angle will be equal. Axiom 6.4 is inverse. Inverse means what? In inverse way, it is if a transversal like L intersect 2 lines M and N intersecting such that a pair of corresponding angle is equal. If a line L intersecting M and N 2 lines corresponding angles means 1, 5, 2, 6, 3, 7 and 4, 8 is equal. A pair of corresponding angles is equal. Then these two lines to which the L is intersecting, these two lines are called parallel lines. That is given such that a pair of corresponding angles is equal. Then the two lines are parallel. These two lines will be parallel. So it is inverse of this. In this, the transversal intersecting parallel lines, then corresponding angles are equal. And in this next number, if the line is intersecting, line L is transversal is intersecting two lines and corresponding angles is equal, then the two lines are parallel. Means the condition is if these two lines are parallel, then only corresponding angles are equal, and if corresponding angles are equal, then only two lines are parallel. Right. Now theorem 6.2 we have. It is about the alternate angle. If a transversal intersects two parallel lines, L transversal intersect two parallel lines M and N, then each pair of alternate angle is equal. Alternate angle will be equal. Alternate angle, that is Z making angles, means this Z is angle 4 and 6, angle 3 and 5 are equal. If the L means transversal is intersecting two parallel lines, then alternate interior angles are equal. The alternate angle is equal. Pair of alternate angles is equal. And this 6.3 is also inverse of this 6.2. It's reverse. In this 6.2, once again, in short, what was given? If the M and N lines are parallel, the transversal intersecting two parallel lines. If the lines are parallel, alternate angles are equal. That was the 6.2. And 6.3 is, in short, what is? If alternate angles are equal, these two lines are parallel. So precisely what we have to see here, if a transversal intersects two lines such that a pair of alternate angle is equal, if pair of alternate angle is equal, then these two lines are parallel. Then the two lines are parallel. Okay. Next, see theorem 6.4 is, if a transversal intersects two parallel lines like this, the transversal L is intersecting two parallel lines M and N, then each pair of allied angles, what is allied angle? Is interior angles on the same side of transversal or consecutive interior angles or allied angles or co-interior angles. Any one name with that we can indicate this. Allied angle is supplementary. What will be the relation in allied angles? Allied angles means interior angles on the same side, means 3 and 6 will be supplementary, means sum of these two will be 180 supplementary, and these also 4 and 5, sum of 4 plus 5 will be 180 supplementary angles. Once again please see, if a transversal intersect two parallel lines, then each pair of allied angles, that is 3, 6 and 4, 5, and the interior angles on the same side of transversal is supplementary. This total will be 180. And its reverse is theorem 6.5, inverse of this only. If a transversal intersect two lines, transversal intersecting two lines, such that interior angles on the same side or allied angles or consecutive interior angles or co-interior angles, we can give any four name. If they are supplementary, like 3 and 6 are supplementary, 4 and 5 are supplementary, that means the sum of 3 and 6 angle is 180, or sum of 4 and 5 is 180, that is supplementary, then these two lines between which this allied angle is made are parallel lines. That is here. See, if a transversal intersect two lines such that a pair of interior angles on the same side of transversal, that is also called allied angle, also called consecutive, also called co-interior angles, is supplementary. In that way it is intersecting that interior angles on the same side is supplementary. Then the two lines, these two lines are parallel lines. So this is so important theory for us to understand, because on the basis of this theory only, the next coming examples and next coming questions, the exercise we can solve, we can prove. So you are suggested to write this with the figure and understand it. At least 2 times you write down, 2 times you see the video, to understand it very well and on it. For next coming examples and next coming questions, this is so important, very, very important.